Okay, let's dive into symbols. Well, what are they? They're just new primitives like strings and numbers, but it's a little bit different. But why do we need them? Well, most of the time they just help to prevent overriding important key names inside of objects, and sometimes they're used to store unique values. So right here, I created two symbols. Okay. You create it with the capital S symbol constructor, and whatever you pass inside a string, that's just the label name for your symbol. Now, whenever you call symbol, you don't actually need to put a label either. So sim3, I would just this, and then I can do sim4, calling it with no arguments either. Okay, so every time symbol is called, what happens underneath the hood is that JavaScript actually has to call a C++ function in order to generate a unique value. So what do I mean by unique value? Well, whenever you call symbols, even 100 million times, JavaScript has to make sure that it always generates a really random key or value, but it also has to make sure that those same values are never ever repeated. Okay? And in order to get that done, it needs direct access to the computer's memory. And JavaScript cannot do memory management. What it can do is that it can call its internal C++ functions. And since C++ is a lower level language, you can directly manipulate your computer's memory. And that's why you do not use the new keyword in front of symbol. Like every other type, right? We can do const str is equal to new string, right? But you cannot use the new keyword with symbol because remember the new keyword is when JavaScript constructs an object wrapper around something like a string, an array, a function. Symbols must be constructed directly by calling C++ functions. So that's why you cannot use the new keyword. Now, these labels like this does not mean that sim1 is equal to sim2. Okay? Just because something has the same label does not mean its internal contents are the same. Okay, same with sim3 and sim4. Sim3 is triple equal to sim4. Nope. Okay. Now, the thing is, we don't get to see what the generated value is when symbol finishes running. Okay? But it can check the value for you internally. So if you say, let's do const symbol 5, it's going to be equal to symbol 1. And then you can do sim5 triple equals to sim1, and it will say true. Why? Because this is a primitive type. And when you're comparing primitive types, JavaScript actually checks the internal randomized value inside a symbol. Okay, let's move on. Okay, let's see a use case inside of an object. Here, I have a regular object. It has a name property and a password property, and then I console.log it. Now, since both name and password are public properties, you or someone else on your team might accidentally or intentionally change the password, right? Because right now you can do obj.password is equal to 0, and that changes it. But what if we don't want someone to be able to do that? Okay. What if we want this key to be a uniquely generated symbol, right, that we can still access and get 1, 2, 3, 4, but no one else will be able to change it? Okay, let's see how we can do that. Let's do a const password is equal to symbol, and I'll call this label Philip's password. You can call the label whatever you want. Okay, but how do we use this here? Well, remember, if you want to use the variable name evaluated as the key name inside of an object, you need those array closing parentheses like that. Okay, now if we look to the right, our obj has a property name, value is Philip, but now it has a symbol with the label that says, hey, this is Philip's password. And it's 1, 2, 3, 4. Okay. Can we still change the password like we did before? Can we do obj.password is equal to, let's just say, changed? Does that work? Yeah. So now we have a public property password that says changed, but Philip's password was never changed. Okay. Because doing dot notation or even bracket notations, we put in password like this, it does not affect the symbol keys. Okay? Because if you look right here internally, the key name for this is not password. It's a randomly generated unique value that the engine has provided for us. But now how do we check that? How do we console.log so that we get 1, 2, 3, 4? Well, we have to know what the generated value is associated to. Like, what is its variable? Well, we're going to console.log obj, and we have to use at so that it evaluates the variable at password. See, and then now we get 1, 2, 3, 4. And this is cool because no one else can ever rewrite your key name because they don't even know what it is, right? It's a really long and unique value. So that also means it can never be duplicated, which is good. So then why don't we just use symbols all the time? Well, first of all, it's really hard to read and it's very memory intensive. Remember, you have to call C++ functions to create symbols. Okay, let's take a closer look. Now I'm going to add an age property 33. And then I want to grab an array of all of these property names. And remember, we can do that by console.logging, capital object dot keys, then passing in obj. Let's see what we get on the right. So as you can see, we only get name and age. Even when you type in obj, you see that there's a symbol here, but it's not listed under keys. What if you do object dot has own property, and then you just type in password? You see that false. But what if we use square brackets? Let's see, if we type in password and then evaluate it, let's see what it says. It says cannot convert a symbol value to a string. So that means when I say symbols create a unique value, it doesn't mean it's a unique string. It's actually a value that contains many different types, such as strings, numbers, and a bunch of other stuff that I'm not even sure about. And this is another reason why we cannot just console.log the direct value of a symbol, because our browser is not able to display that. Okay. I hope that was helpful.